Today we're going to talk about the 502. I've been putting the word out there on some of the questions and answers that I've got on some other videos that I'm going to do a 502 build. So I want to talk to you about big block Chevys for a minute, because back in the day there's basically three generations of big blocks that you're going to be dealing with nowadays. Generation 4, 5, and 6. Or Mark 4, Mark 5, and Mark 6. Now, Generation 4 is the typical big block Chevy 396, 427, 454, 366 truck motor that they've been around since the mid-60s. Right? The first year for that Generation 4 big block was 1965. They had another big block before that. It was a previous generation. It was like a 409, but it was a totally different engine. It wasn't the same thing, but they did consider that a big block. But the ones that we know about are the Gen 4s, which is 1965 on up. In the 90s, they went to a new generation of block. They went to a Generation 5 block. Now, the Generation 5 blocks are okay, but I'm not going to focus on those in this video because the 502 that we're going to do a build on is a Generation 6. The Generation 5 blocks, the interchangeability of the 5s was not really as good as it should have been. And I kind of tend to think that the reason that Chevy came out with a Generation 6 big block is because they wanted to fix some of the things that they overlooked. So there are some similarities and there's also some differences. So we kind of need to talk about that. The Generation 6 big block Chevy came in 454 and 502 versions. Now, I want to talk about the components here for a minute. This is a set of pistons that I picked up, and I actually considered doing a 540 till I found these. Plus, I checked the bore on my block, and the bore on this 502 is a good standard bore. Well, it is now. We had to put two sleeves in it, but it's a good standard bore after we put two sleeves and repaired two of the cylinders. I wanted to keep it standard just because the other bores were in such good shape. Now, you can bore them over, and it might be feasible to bore it if you got bore issues, but I have a machine shop, so it was not a big deal to put sleeves in. So this is the pistons that I've selected for it. Now this is this piston is made by J&E, but it is actually it's a takeout. A buddy of mine had a 502 crate motor that he bought years ago, and he wanted to put a blower on it. So what he did is he took the original pistons off, and this is original piston from GM right out of the crate, and it has a slight dome on it. It's not a real big dome, but it's just raised just a little bit. And so this is a forged piston, and what you'll notice is inside it says JE 700. This is it's a piston that J&E made for General Motors for the 502 crate engines. And so this piston is typically, it is a forged piston, and this a lot of times is what you'll find in the 502s. Now, I'm planning on running Gen 4 781 heads on this engine. And the reason I say that the Gen 5 engines had some compatibility issues, because you really got to watch out if you want to run like a set of 781s or the early generation heads on the Gen 5 block. They had a tendency to leak. The water jackets on the Gen 5 block were pretty big up by the lifter valley, and a lot of times the Gen 4, the early 781 heads or whatever you put on there, would leak coolant into the water jacket. Well, you don't want that. The nice thing about the Gen 6 blocks is they've corrected that problem, and now you can run the Gen 4 781s or whatever on them as long as you use the right gasket, and it works pretty good. You don't have any leakage problems. So the pistons, the JE 700s, this is a factory piston. They do have metric rings on them, so it might be kind of hard to find rings. The nice thing about this set here is these are brand new. They've never been run. They were just taken out of that engine. The The rings are kind of a little bit of an oddball size because they're metric. You can get these. I know Total Seal does have replacement rings for these pistons. I'm going to go ahead and run these because this isn't going to be that radical of a motor. And besides that, these are J&E rings. J&E not only made the pistons for GM, but they also supplied the rings, and they're pretty good rings. This is the typical ring that came in the 502 crate motor. So that's a good set of JE 700 pistons that we're going to run. The connecting rod. So this is the rod that came in it. Now, you've probably heard the term dimple rods. And what they mean is you can probably see that there is a little dimple right there on the rod. That's called a dimple rod. Now that is a GM rod. It's the standard length 502 rod, which is 6/135, I believe. And the stroke of the 502 is the same as the 454. It's got a 4-inch stroke, and it just has a much bigger bore. So the dimple rods are really good. Of course, we're going to put new ARP bolts in these, and we're going to resize them to make sure that the lower end is round and we got some good solid bolts in here. But these are very strong connecting rods. It's an upgraded rod from the stock big block Chevy rod. So what you want to look for is the rod with that dimple, and a lot of the 502 crate motors came with the dimple rods in them. If you're doing a street rod motor or whatever, these rods are really strong. You don't really need to go aftermarket rods because these will do the job for you. So the connecting rods and the pistons are basically going to be duplicating what the 502 had in it from the factory on this build. This is a 6-inch 135 thousandths connecting rod. The piston compression height. Now let me explain to you what piston compression height is. The piston compression height on the JE 700s, that is from the center of the pin to the flat spot of the piston. On this engine is, I wrote it down here, 1-inch 645, 1-inch 645 thousandths, which is designed to work with that stock length connecting rod. The crankshaft is 4 inches, so if you take the 4 inches of the crank and you cut that in half, which is what's going to be in the equation for, right, this is going to be in there, plus half the crank stroke is going to be down here. If you add all three of those together, you come up with just shy of 20 thousandths below the deck on this motor. So the deck height is 9-inch 800 on a 502, and if you add the piston compression height, the rod length of the dimple rods, and half of the crankshaft stroke, you get 9-inch 780, which is 20 thousandths. So that means the piston should sit down in the bore 20 thousandths. Now, I am probably going to set this block up and deck it because I ran the compression ratio numbers with the 781 head, which is about 120 cc's. Might be a little less after we deck them. I'm going to have to cc the head. And this piston with this just slight dome on it, it comes out to right at 8.8 to 1 compression. Okay, now keep in mind this is going in a C30 1-ton, 66 C30 1-ton truck that's going to pull a trailer, but it's also going to be kind of a street roddy type thing. It's not going to be real super radical. I'm going to go a little bigger on the cam than stock, of course, and you can actually get away with when you got this kind of cubic inches, even if you're pulling a trailer, you can actually put a little more of a radical cam in, and you don't have to worry about losing torque or anything on the low end because my goodness, the 502 has low end torque up to yin yang. So you can get away with a more radical cam, even one that has a little bit of a rough idle, and you can still have gobs of torque on the lower end. So that's kind of the plan. I don't want the truck just to be a work truck. I want it to be able to pull my car trailer, but I also want it to be able to, go down to the car show on Saturday night and pop the hood. I want it to look good and be. I'm probably not going to paint it. The truck's already white. I probably won't. I'm not into really show-car-y custom paint jobs. But I do like really nice engines and powertrains, and I like the things set up good. So these pistons, these connecting rods, and the crankshaft. Now the crankshaft is, for the 502, is forged, and I don't have it here because it's out at the crank shop. Unfortunately, the crankshaft in this motor spun a rod bearing, and it hurt one of the rod journals pretty bad. So I got it over at 5 Star here in Glendale, Arizona. 5 Star has one of the best local crank grinding, crank repair guys in the state of Arizona here. So he's been working his magic on the crankshaft. The block itself, so let's take a look at this block. I know I did a video where we actually kind of did a little overview when I tore this thing down. Let's take another look here. Okay, so on this cylinder block here, the 502 block, now one of the nice things about the Gen 6 502s and 454s is they all had 4-bolt caps. It's a 4-bolt main. And unlike the 350 Chevy, the front cap, and I'm missing a bolt there, I'm not sure where that went, but I'll find it, and the rear cap are both 4-bolt, and then they're 4-bolt all. And of course, these are set up for a windage tray. That's what these tall bolts are here. Now, in the early Gen 4 block, it was a little different here where the oil filter mounting goes. It had a recessed mounting. It was machined down in. This one's pretty close to being flush. And also on this block, you have a couple of oil gallery holes that are machined and tapped, and these are for your oil cooler lines. I will probably run an oil cooler on this since it's going in a truck, but this differs a little bit. The other thing that this block does not have, if you look on the side here now, if you're running a standard transmission, normally this boss here is drilled. That's an oil gallery hole there. But normally this boss here is drilled out for the ball and linkage mechanism that screws in. Well, the Gen 5 and 6 blocks didn't have that machine. I suppose you could drill and tap that if you really wanted to, but they actually have a bracket that goes on and replaces that. One thing you'll notice here, let's try to look inside the cylinder. You can see inside this. This engine has Siamese cylinders. In other words, there's really no space in between them. It's got this big giant bore. They were pretty stable. These cylinders were pretty good. They weren't real weak. The 454 cylinders, the 44 Gen 6 cylinders, I've heard some people say they're a little bit on the weak side, but the 502 is a pretty stout cylinder setup. The cylinders are Siamese and they're pretty strong. If we look at the bore here, this is our nearly 4.5-inch bore, which is ginormous. And also the deck surface, you'll notice that the water passages are a lot bigger. Up here, they've made these a little smaller. This is the lifter valley over in here, and if you look at the Gen 5 block, these are much bigger, and there's not as much meat in this area. It's just a little bit different design, and the early heads can leak this way, but they've solved that problem with this one here. So, and also you're going to see 8.2 cast onto the block if it's a 502. If it's a 454, it's going to say 7.4 here. So that's another thing you want to look for when you're looking at these. We go up to the front of the block here. The front of the block has a machined pad up here, and it also has, if you look at these two little holes here, these two little holes are for a retaining plate for a roller cam, because this block was it came with a factory roller cam. Now what's interesting to note is this particular 502 did not have a roller cam in it. It had a flat tappet cam. So it'll take either type of cam. GM did sell some of these crate motors for a lower cost with a flat tappet cam, even though the block had provisions for a roller. And of course these are your oil gallery holes here. And if you look on the front of the block, it says Mark 6, which is basically Generation 6. So now we go up to the top of the block here, and this is where you're going to see some pretty big changes. The Generation 5 or the Mark 5 block did not have provisions for a roller cam. The Mark 6 does. So what they did They actually have a taller lifter bore here, which gives more lifter stability. We have, these are the bosses that are for the spider assembly that goes in here that holds the lifter retainers down. So, and it also has, if you'll notice, a machined pad here. This machined pad is for the lifter retainer, or the crow's foot, whatever you want to call it, that goes in here. We also have these 3 oil galleries holes here. There's 1, 2, 3, and these had plugs in them. One of the things that a lot of guys will do is they'll tap into one of these lines here, and they'll run up through the cylinder head here, and they will put a little spray bar inside the rocker area for better lubrication on high RPM engines. I'm not going to do that because this is not going to be a real high RPM deal. This is just going to be a truck engine that's hopefully going to make 650 to 700 foot-pounds of torque. If I get in that range, I'll be happy with it. And that's basically it for the big block. I mean, I don't have the crank here, but hopefully you're jazzed about this. So I appreciate you watching. Make sure you subscribe below, ask any questions or comments that you have, and I'll talk to you soon.